Good morning, everyone. My name is Yizhu Wang. I am an undergraduate student from Tsinghua University. I conducted this research when I was visiting at UIUC. Today, I'm excited to share our work on explainable SMS phishing detection using large language model agents. The financial impact of SMS phishing is growing rapidly. According to the US FTC report from 2020 to 2024, losses have increased from $75 million to over $400 million. And older adults are especially vulnerable. They tend to lose more money when targeted. To ensure that our system effectively supports older adults, we intentionally recruited more of them in our study. Detecting phishing in SMS messages has unique challenges. First, SMS messages are very short and provide limited text for analysis. The shortened URLs are also widely used in both legitimate and phishing messages. The URL shortener hides the real domain name of the destination URL, so their appearance alone is not a reliable signal. Caller IDs are also unreliable because they are easily spoofed. So, it is not enough only to analyze the textual features. We need to go beyond them, and we need more context to make accurate and trustworthy decisions. Another challenge is the vague decision boundary. Between legitimate and phishing, there is a large gray area, spam. Here, we define spam as promoting risky services like gambling or adult content without impersonation. The difference between spam and phishing is that the spam messages do not lie about who they are, but phishing messages pretend to be someone else. Many existing phishing detectors on mobile apps will simply issue a generic alert saying something like, "This message may be a scam," but they don't explain why, so users are left confused. Users cannot understand why this particular message is flagged. So, we want to bridge this gap. Our goal is to build a large language model agent system that can collect more contextual information and detects phishing accurately. Also, provides explanations of its decisions to users. We developed SmishX, a system powered by large language models. Given an SMS, it first extracts key elements such as the URL and brand name. Then it collects supporting context information. The supporting context information includes URL's redirection chain, its domain history, the HTML code, and the screenshots of the linked page, and the search results for the brand name. For the search results, we collect the top 5 URLs from Google. The rationale is that phishing websites typically cannot outrank a legitimate official website in a Google search. These contexts help the system better assess the message legitimacy. Then we feed all these contexts into a reasoning LLM, which performs a step-by-step analysis and classifies the message as phishing, spam, or legitimate. It then generates a detailed explanation. Because long explanations may overwhelm users, especially the older adults, we use a second LLM to summarize the reasoning into a short, simple explanation that includes the decision, a brief explanation, and a safety advice for users of the specific message. Then, we tested our system. We tested SmishX on a dataset of 1,200 messages, and we compared it to baseline models. Our system achieved an accuracy of 98.8%, outperforming the baselines. And more importantly, it is the only system that provides explanations for users. To evaluate how people interact with our system, we designed 4 research questions. First, we want to know how effective is the AI agent in helping users recognize phishing SMS. And second, we want to know how do users perceive the usability of this AI agent. And third, how does the AI agent influence users' trust in AI and their self-confidence in detecting phishing messages? And under what situation would users disagree with the AI agent? And last, how do users respond to the AI agent's mistakes? To answer the first 3 questions, we run the user study A with 125 participants. To answer the last question, we run a parallel user study B with 50 participants. We recruited the participants through an online platform Prolific, and 40% of them are older adults over 65 years old. They took the user study at home with a laptop by visiting our website. Every participant started with a short pre-task survey where they answered demographic questions and rated their confidence in detecting phishing and also their general trust in AI systems. Then came the core of the study, the message evaluation task. Participants in study A evaluated 10 messages, 5 phishing and 5 legitimate. And the participants in study B saw the same 10 messages plus 1 special message where AI makes a critical error. The message is actually phishing, but the AI mistakenly says it is legitimate. The messages are randomly ordered for each participant. For each message, participants made an initial judgment. They decide phishing or legitimate based on their own intuition. Then they click a button to view the AI explanations. And then they made a second decision after reading the AI's report. Finally, they completed a post-task survey. The survey included the system usability score, or called SUS, which consists of 10 questions and yields a score from 0 to 100. A higher score indicates better usability. Participants also answered open-ended questions about what they liked and what they disliked about the system. They are also asked for explanations if they have ever disagreed with the AI agent. At last, they answer follow-up questions about trust and confidence again. Now, here's what we found. First, the AI significantly improved the user's accuracy. Before seeing the explanations, their average decision accuracy was about 71 participants. Afterward, it rose to 93% participants. The older adults' accuracy are also improved. Second, the system received a usability score of 82 on the standard SUS scale, which is rated as excellent. We also saw that both trust in AI and the user's self-confidence increased significantly after the study, showing that SmishX not only helps users make better decisions, but also helps build trust in AI and educates and empowers users. Next, we looked at how users disagree with the AI. Interestingly, users are more likely to disagree with AI when the ground truth label of the message is legitimate. Users often insist the message is malicious, despite AI's suggestion is legitimate. About 11% of this time, and compared to only 3% when it flagged the message is phishing. The most common reason was about shortened URLs. Even when the AI said the URL was safe, users remained skeptical. This actually suggests that legitimate services should avoid using shortened URLs, and instead, they should display their full domain names to build trust. We also found that users often relied on their personal context. If someone wasn't expecting a delivery, but they received a delivery message, they were more likely to flag it as phishing. But if they were really actually expecting a package and they do receive the message, even when the message is phishing, even when AI raised red flags, they still tended to believe it is legitimate. This shows that the personal context strongly shapes users' judgment. The final part of the study, we examined what happens when the AI makes a mistake. In study B, participants saw one phishing message that was misclassified as legitimate. Initially, 24 users correctly identified it as phishing. After the AI's incorrect explanation, only 6 users stuck to their original answer. The other 18 changed their mind to match the AI. This shows that the users can become overly reliant on AI. To reduce this risk, we propose using more adaptive, cautious, and conservative language in the AI explanation. For phishing cases, The message could say the message is likely a phishing message because, and do not click the link or reply. And for the messages that are labeled as legitimate, the system could instead say, no strong evidence of phishing was found, but please verify through official channels before responding. The kind of phrasing encourages users to remain cautious, especially in uncertain situations. To sum up, we built SmishX, a system that combines high-accuracy phishing detection with clear explanations. Our user studies show that it improves detection accuracy, earns excellent usability skills. We also learned that users are more skeptical when AI says the message is legitimate. And the over-reliance on AI is a real risk when mistakes occur. Overall, we hope our work contributes to building more transparent, trustworthy, and educational AI security tools. All our code dataset and materials are available on our GitHub repo. And thank you very much. Please check out the full paper for more details. I'm also currently applying for a PhD program, so if you are interested in my work or have any potential opportunities, I'd be very happy to connect. Thank you.